Hello, good morning, year 13 calculus. Now, I'm just going to give you, I considered it would be good for you guys to have another example of how to integrate Trig products. So I've gone and done this extra example. Okay, so let's talk you through it. Well, you're being asked to integrate sine 6x multiplied by sine x. Okay, so don't forget x and 6x must be two different angles. This obviously is 6 times the size of that angle there. Okay, now you're multiplying sine with sine. And when that is the case, you must use this identity here. Okay, don't forget we're using these identities because this is the only way in which we can integrate things like this. All right. Now, so the trig identity here is that the sine of A multiplied by the sine of B can be rewritten as the cosine of the difference of these two angles minus the cosine of the sum of these two angles. Okay. And this 2 here, you could multiply down here to multiply everything of this by 1/2, and you can see that it's crept into the rearranged thing here at that point there. Okay, so let's see how we do this thing. Well, we're being asked to integrate sine of 6x multiplied by the sine of x. Well, that's going to be equal to 1/2, that's that 2 coming down there, to divide all of that side of the equation by 2. It's the integral of the cosine of the difference of these two angles, 6x and x, so that's obviously going to give you 5x, minus the cosine of the sum of these two angles, 6x and x, which is obviously going to give you 7x there. And immediately you can see that you're beginning to get something which is far less frightening to integrate. So we can now bring this integral sign in and do the two separate integrations. And you'll notice I've used these square brackets because you must not forget that this half is multiplying all of this inside here. So whatever you get for this integration, whatever you get for that integration, it's all going to be multiplied by that half outside the square brackets. Okay, so how do we integrate cos 5x? Well, you say let u equal 5x, and so you differentiate that, you get du by dx is equal to 5. And then if you cross multiply the dx, you get that 5 dx must be equal to du. There it is there. However, of course, as you now know, you should know by now, that if I've multiplied the dx by 5, I've also got to divide by 5. And that 5 here in the denominator can go in front of the integral sign as 1/5. The same is true here of this cos 7x. This time I'm saying let v equal 7x, and then dv is going to be equal to 7 dx, but I must divide by 7 as well to keep the integral the same value. So that 7 in the denominator can go in front of the integral sign as 1/7, like that. So now we've got an even simpler looking integration to do. We've got the integral of cos u du and the integral of cos v dv. Well, cosine is the derivative of sine. So the answer to this is sine u, and the answer to that is sine v. This time there are no sign changes, of course. So what do we get? Well, this 2 will now multiply it with the 5 to give us 1/10 sine u, and this half will multiply with the 7 to give 1/14 sine v. Okay, and that is it. You now replace the u with the angle that you started with, 5x. You replace the v with the angle you started with, 7x, and there you write out your entire answer. Don't forget the plus C on the end. Okay, I have uploaded the exercises. I'm afraid they are vertical on the page. You may have to turn your head about or try and turn the image round to get at them. But if you have any problems, please don't forget to post your concerns up on the Teams page for our class, and I'll do my best to answer them. Okay, thank you very much.